So in this video we're going to be solving the system of equations using the substitution method. So the first step we want to make sure we have is that one of the equations with a variable by itself. And if we look at the second equation already has x by itself. So we met the first step that we need. I like to put it in a box so I can find it easier later as I need it throughout the problem. Now that the first step is done, we're going to go on to the second step. We're going to look at the other equation, which is 2x plus 5y equals -5. And the second step is to replace, in this case, x in the equation written in blue with -3y plus 3. So I'll replace my x 2 times with -3y plus 3 plus 5y equals -5. So that's that second step. Third step is just to solve this resulting equation. So we're going to have to distribute -6y plus 6 plus 5y equals -5. Combine like terms, which is -1y plus 6 equals -5. And then solve. So subtract 6. We get -1y equals -11. And divide by -1. So y is 11. And all of this solving process will be the third step. The last step we need to do is we need to take our 11 and plug it back into one of our equations. It doesn't matter which one we use. I usually use the one that I put in the box earlier. So x equals -3y plus 3. I'm going to replace y with 11. So x will equal -3 times 11 plus 3. So we have -33 plus 3, which is -30. So x is -30. If we wanted to write that as an ordered pair, the answer would be -30, 11. This part was the fourth and final step. In this example, we're going to be solving the system, once again using the substitution method. So in order to do substitution, we need to have one of the equations with a variable by itself. Both equations actually have a variable by itself, so I'm just going to start with this one. I'll put that one in a box. For the second step, we go to the other equation, and we're going to replace the y with what the first equation says y is equal to. So the first equation says y is equal to x minus 4. So we replace the y in the second equation with x minus 4. The other side just comes down. Essentially, if both equations have y by itself, you just set the equations equal to each other. Afterwards, you need to solve the equation. Actually, let me number my steps. There we go. The second step. Afterwards, we're going to solve the equation. So we need x's on one side. So I'm going to go ahead and subtract x from both sides, giving me -4 equals 1x, which is really just x, minus 2. And then we just have to finish solving, add 2 on both sides. So -2 is equal to x. There's our third step. And the fourth and final step is to just plug it the -2 back in so that we can figure out what y is. So I'm going to use the one I put in the box there. So y equals x minus 4. We'll replace x with -2. and then just finish solving. So negative 2 minus 4 is negative 6. That's our fourth and final step. So overall, our answer is y is negative 6 and x is negative 2, or as an ordered pair, negative 2, comma, negative 6. In this example, we're going to be solving the system of equations using substitution method. So in order to do that, we need to make sure one of the equations have a variable by itself. This time, neither equation has a variable by itself. However, we can get one of the equations to have that situation. Sometimes there's easier ones to solve for, sometimes there's not. In this case, if you look for a variable without a coefficient, that's probably the one you want to get by itself. It will be the easiest to do that. So in this case, my y in the first equation does not have a coefficient, so I'm going to use that first equation. I'm going to get y by itself there. To get y by itself, I need to get rid of the negative 3x. I will add 3x to both sides. We'll have y equals negative 9 plus 3x. We now have y by itself, and I'll put that in a box for later. So step 1 is done. Now I'm going to cross off the original equation so I don't accidentally use it here. We can't use that equation again. But we're going to move on to step 2. Step 2 says we're going to go to the other equation, this one here. We'll replace the y in this case with negative 9 plus 3x. So I'm going to be replacing y with negative 9 plus 3x. Replacing my y with negative 9 plus 3x. So that's step 2, is to get that set up. And then step 3 is to solve this equation. So we'll have to distribute. So we're going to have our 5x coming down, minus 36 plus 12x equals 32. Compound like terms. We have 17x minus 36 equals 32. Add 36 on both sides. 17x equals 68. Then we shall divide by both sides by 17. And 68 divided by 17 is 4. So again, this whole process here was our third step, just trying to solve the equation that we get. To finish the problem, we still have to figure out what y is. So we're going to go back up to the equation that we boxed earlier. And we'll replace the x in that equation with 4. So we're going to have y equals negative 9 plus 3 times 4. 3 times 4 is 12. And then negative 9 plus 12 is 3. So we have x is 4, y is 3, or as an order pair, 4, 3.